start off, I'm going to ask a couple survey questions in the tradition of some of the other sessions we've had here. So how many of you here have, how many of you here use VMware products currently? All right, that looks pretty close to 100%, maybe not absolutely 100, but pretty close. How many of you are currently using any sort, VMware or otherwise, of self-service provisioning solution where you have users that can log into a catalog? Okay, that's quite a few. Well, maybe 20, 30%. How many of you are planning in the next year to try to deploy a self-service provisioning solution? Okay, a couple more. So there's some people who this is going to apply to. So the information I'm going to be going over is going to be a little bit more generic than just being 100% VMware specific. We're going to talk about some of the general properties and things that we have to do to be able to use Puppet with any sort of self-service provisioning engine. Some of our examples may be in VMware specific software, but you could take those same ideas and apply them across a range of other solutions. So a little bit about myself. My name's Justin Jones. I am a senior consultant at VMware and Professional Services. So anytime somebody comes to VMware and asks VMware to integrate one of our products with a third-party product, or they want a feature that isn't currently out of the box and they need somebody to write that for them, they usually come to our team, and we're the ones who actually code that and develop it for you. If you're looking for me on LinkedIn or Twitter, my information's up here, and here's some examples of a couple clients that we've done work with on our team that I've been a part of. So first thing here is we're going to talk about the traditional VM delivery triangle. So you've probably seen these delivery triangles before where you have three sides, and essentially you're saying, in most cases, you can only have two of those particular attributes. So we have fast delivery up here, fully configured, and customized. So essentially, in traditional VM delivery, if you're going to build a VM that's fully configured, meaning that you've gone over it very carefully, made sure it's standards compliant, and it's also customized so that you have the software packages the user wants, it's typically not delivered very fast. You may have an SLA of 1 or 2 or 3 weeks. I've seen them going into the months. Likewise, if you give fast delivery and it's fully configured, you're probably using a template of some sort, and it's not going to be very customizable. You're not going to be able to request a particular package to be installed. And then your last combination there is fast delivery and customized. If you do that, typically your configuration is going to suffer. It's not very consistent. Yeah, you don't have a lot of processes and you can pump out VMs quickly, but they're not always very consistent. So the promise that you see from these sort of configurations is that you're going to have machines that are all three of these. That's what you want when you're talking about self-service provisioning. So that's usually the promise that we've seen, that's what's driving and selling these self-service provisioning solutions. So give me just a second here. All right, so essentially organizations are trying to script and configure their customizations. If you're trying to script your customization and configuration, a lot of times you're going to actually have a lot of issues with scalability and being able to adjust that. Give me just a second here. I'm going to actually exit. I'm having an issue with presentation mode, so I'm just going to change to mirroring this display real quick. Be a little bit easier. I can't quite read it on my laptop without being right on top of it. I'll just do mirror. Go. All right, let's see if that works a little bit better. All right, still haven't. All right, so when organizations are trying to script and configure, The issue that you have here is really that your scripts aren't scalable. As operating systems get updated, as product versions change, there's too much overhead to try to maintain these. And so as we've been talking about all today, if you actually are using your desired state configuration language with a solution like Puppet, you can kind of resolve this problem. So benefits for administrators too, in addition to just having the capability of being able to, the previous slide we were talking about the benefits to the users, but there's benefits for the administrators too, right? The administrators are going to be handling a large number of virtual machines, and without centralized management, configuration drift and standardization across the enterprise is a big problem. So, let's see. All right, so two main types of self-service provisioning that I'm gonna refer to. So that's infrastructure configuration and infrastructure customization. So this is the kind of the differences between these two types. Let's see. I'm gonna make this a little bit bigger so I can see it without having to back up here, but having a little issue there. Yeah, that didn't work. Sorry about this. Screen. All right. Still not mirroring. All right. Does anybody know how to turn off presenter view and Mac OS? I just want to have sorry about this. This is taking me a minute. I guess I can just put it up here like this. All right. Can you read it like that? All right. We'll just do it like that then. All right. Sorry about that. All right, infrastructure configuration and infrastructure customization. Differences between those. On infrastructure configuration, you're sharing VMs and you're talking about your Puppet code that's shared between all the VMs in the environment. This is your core stuff like maybe NTP settings, admin security counts, etc. Customization is going to be stuff that's specific to that particular VM configuration. Things like if it's a web server, an app server, a database server, and we're going to discuss two models there. So a la carte design pattern and roles and profiles. If you've been around Puppet for a while, you've probably heard of the roles and profiles design pattern. Essentially, when you're talking about roles and profiles, you're referring to choosing one group membership and only one that can be have a lot of different classes in it, but you're not going to have multiple group memberships where with a la carte we can. So differences here. Design patterns, if you haven't heard this term, I know there's some people here who are new to Puppet. Essentially, it's similar to what other organizations term best practices. Idea is that no one solution is necessarily one size fits all, and what's best practices for one org may not be for another, right? So you can kind of choose from a couple different ways of doing things, and the way that you've chosen to do it, other people may follow that, and you may call that pattern a design pattern. So roles and profiles design pattern, essentially a single role which maps to a Puppet group is chosen, and that defines everything that Puppet configures on that system. You don't have membership in multiple roles. That's just not allowed. If you needed to be in two roles, you'd essentially create another role that contained the code for both those roles and be just a member of that new single role. A la carte design pattern, this is a term that I've come up with. And essentially what I'm referring to there is just standard options where you're going to present the user with a menu of choices, and they can multi-select. They can choose 1, 2, 3, 4, 20 if you have that many. And invalid combinations need to be prohibited in the user presentation layer in your UI. So let's look first at the a la carte design pattern. So yeah, this is huge, so you should be able to see this. What we're looking at here is, this is actually vCloud Automation Center, or vRealize here, and you have a customizable UI. And if you look down here, essentially what I've done is made some offerings for, do you want a backup client installed? Do you want monitoring agent? Do you want Apache installed? Do you want MySQL installed? And the user can check any of these. It's multi-select checkboxes, so they can check 1, 2, 3, 4 of them, none of them if they don't need any of these. So in your environment, or in your programmers would have to actually implement this in such a way. You may say, you know what, having Apache and MySQL on the same box is not a valid configuration. If that's the case, you might do something here where when you check MySQL, the Apache checkbox automatically grays out to prevent that combination. So this maps in our a la carte design pattern essentially to node classification here. And so what I've done here is, this is, these screenshots are in 3.7, but if you look down here, you'll actually see we have a couple groups that I defined. You see VMware Apache, VMware Backup Client, VMware Mandatory, VMware Monitoring Agent, and VMware MySQL. So the idea is with a la carte, you could be at any of these, but these blue ones are elective. This red group is essentially always going to be applied to all the nodes that I deploy. The user doesn't choose to check that or uncheck that. They're always going to get DNS servers. They're always going to get NTP config. We're always going to put a backdoor admin account on there, or whatever it is. All that Puppet code is applied in this particular group. These other ones are elective, so if the user checks that they want backups done, we're going to actually use Puppet to install and configure a backup client. And that could be Net Backup or whatever your particular backup solution is. As long as you can write Puppet code, or somebody can write Puppet code to enable that to be installed and configured, you should be fine there. All right, so in contrast to the a la carte model, let's talk about your traditional roles and profiles design pattern. And this is specifically in the context of self-service provisioning. So for role selection, no multi-select is needed. You're going to choose a single role in the UI. You're not going to choose backup or not. You're not going to choose monitoring or not. And alternatively, each item ordered in the catalog may correspond to a role. So I'll explain what I mean by that in a minute. But here I'm ordering a Linux CentOS 7.0 VM. You know, I have one machine ordered, one CPU, 1 gig of RAM, and it's a very small VM, and I could choose here from a drop-down. Is this an Apache server? Is it a MySQL server? Is it a different type of web server I have here? So there's some different options. Now, when I'm referring to catalog, you could, instead of even having a drop-down here in your menu where the user chooses whether it's Linux or VM, you could even have another catalog item listed there that would be called you know, your data MySQL server, and you automatically choose the OS, etc. So you don't even necessarily have to present this kind of menu. But the idea here is that when they order that, there's not any additional choices to be made. If it's a backup server, maybe you say, or sorry, if it's a web server, maybe you say, we monitor web servers, but we never back them up. There shouldn't be any data that needs to be backed up on a web server. It's a policy decision at the business level that this role corresponds to. Or with a database server, you might say, database servers get both monitored and backed up because there's data that needs to be backed up on there. Maybe it's environmentally different. If you're deploying in dev, then nothing gets monitored and no monitoring agents are ever loaded. So you have a different role for web server and dev versus web server and prod, and you would differentiate those here. So roles and profiles design pattern here, we're looking at the node classification in the Puppet Enterprise console. Nodes can be a member of only one group, and that group is called a role. So we've denoted that over here in the left where it says role : : You can see Apache web server, MySQL database server. You see your SSH jump box, which is a sample role I made here. The UI has to be configured, so again, this is repeating myself, so that only a single role would be chosen. So you may say, okay, I understand the difference between a la carte, I understand roles and profiles, how do I decide in my particular environment which one of these I use? So answer to that is it depends, just like everything else, right? Let's look at some of the attributes of the two. If you're talking about a la carte, that provides your users with a great degree of flexibility. That can be a positive or a negative thing depending on your user base. You can allow hybrid systems, web plus DB. Again, maybe you want to do that to save resources, or maybe you want to forbid it because it's just against your organizational policy. And it can also prevent what we refer to as role sprawl, which occurs when you have to have so many roles that they become unmanageable. You find yourself creating and adding new roles on a daily basis to cover all the use cases that your users have. If you're ending up with systems that frequently have invalid class combinations, you may want to consider a roles and profiles model if you're doing a la carte. So roles and profiles attributes, you have a high level of consistency between servers. You know when you see that a role is applied exactly what you're going to find on that server, or for the most part, exactly what's been installed and configured by Puppet. It's easier to enforce compliance, again, because you know exactly how it's been set up, and there's less choices for the user to make. Depending on our user base, again, that could be a good thing to limit the amount of decisions that they have to make, or they may prefer this a la carte model with higher flexibility. If you're getting a lot of role sprawl, you may have chosen the wrong design pattern over here. If you're having to create more and more roles, you may want to consider looking at a la carte. All right, so my next section here that we're going to discuss is self-service provisioning task flow designs. So these are essentially the different things that you have to do to do self-service provisioning integration with Puppet typically. And there may be exceptions or additions or subtractions depending upon your solution, but generally these are some things that I have identified that need to be done. So we're going to start off here at this green box saying we have a user, they've gone to our self-service provisioning catalog and ordered a virtual machine. So in this particular flow, we're going to be using what we refer to as pre-staging and some sort of auto-signing. So pre-stage VM and Puppet via the Rake API. We're going to look at an example of exactly how this happens, but essentially before the VM is ever built in the hypervisor, we're doing a call out to Puppet and saying, say my VM is my VM123. We're going out to Puppet and saying, hey, create a node called VM123 and apply the following classes, infrastructure mandatory and Apache. And it'll actually create that node. It'll never show that it's checked in because it hasn't. In fact, that VM doesn't even exist yet, but it shows up in Puppet. Then the next step is the node actually builds in the hypervisor. So Amazon or VMware or whatever you're using, that virtual machine gets cloned or deployed or kickstarted, however it's built. And then the node's going to power on and boot. And maybe the template already has the Puppet agent baked in, or maybe that you're using something like user data and EC2 that's going to do a run once to install and configure that node and point it at the Puppet master. When that happens, the Puppet node is going to boot up and check into the enterprise console, into your Puppet master, and this is when the magic happens here for auto signing. So there's a couple different kinds of auto signing. Somebody could probably do in excess of an entire hour just on the different types of auto sign that's available. There's policy based, there's whitelist, and there's naive, where you pretty much just assign everything that comes in. Oh, thank you. So depending on what your use case is and what your security requirements are, you may make some decisions here. If you go out after this presentation and download the slide decks online, there's a link right here to information on what those different auto signing options are, and you can click that link and that'll give you some information here. I think there is this, in the community, I get the impression a lot of times that people think auto signing is insecure. If you do auto signing correctly, I don't believe it's insecure. There's some options and some ways here. You can use an orchestration engine like vCenter Orchestrator or something that's a trusted system to manage this auto signing so that you're only auto signing nodes that you know are actually valid. So it's a very valid solution, and I've seen it done in what are very high security environments with success. So don't think auto signing just in general is insecure. It's something that you can definitely do in a secure manner. Now there are ways like naive signing that, yes, you are correct, those are completely insecure, but there are correct ways to do it that give you whatever level of security you need. Here's a second method, very similar to the first. We start over here with the user ordering the VM. We're still pre-staging the VM using the Rake API and Puppet. We're classifying the node before it's ever built. then we're actually going into the hypervisor, cloning it, boots up, checks in, and instead of auto signing it at this point, we're going to actually do a REST API call to sign the cert. So I've done another link here on how to use the Puppet HTTP API to do node signing. Again, this could be another hour-long class on itself of how to do this, but if you don't want to do auto signing, this is a very viable alternative. Part of the issue here is timing. We're really trying to deliver our VMs to our users as quickly as possible. And if we do this, we have to time this so that the Puppet has actually, that the node is cloned, it's booted up, and it's completed a Puppet agent run so that it's checked into the console, at which time, and only after that, can we sign it. And then after it's signed, it also needs to do another run at that point to be able to actually compile its catalog and execute. So if for some reason signing doesn't work for you, there is an alternative. You're probably going to have to use one of these two solutions if you're doing integration with self-service provisioning, and these are a couple of good options. All right, so far we've talked about doing our node assign, essentially by collecting the information out of self-service provisioning. My example was with vCloud Automation Center, and essentially what we did there is I used key value pairs that are customizable in that solution to collect that information, but we have some alternatives here. So let's back up. You've probably seen this before. This is actually pulled out of the Puppet documentation and talk about the data flow, right? So essentially we get facts from the VM when the agent runs, a catalog's compiled, and then we have a report and remediation there. Let's look at an example here. So I've made a fictional roll-up called a SSH jump box, essentially, which is going to be a highly monitored single point where you can SSH into and from that system go over to another system. If I wanted to classify a node, I think we saw this in the Puppet example earlier. I think this is new in 3.7. Essentially, I could do something like, say, FQDN, regex matches. I think that needs to actually be in parentheses, but if it contained SSHJB anywhere in the name, I could automatically classify the node like that. And there's a whole lot of other options that you could make. There's a whole lot of built-in facts that you could use to manipulate your node customization, or you could actually do custom facts again. So we're just kind of going over the possibilities here. Again, custom facts is something that could be a class on all of its own of how to actually build these. But I could, for example, make a custom fact called is Apache. And let me have a brief discussion in the context of vCloud Automation Center, which is also known as vRealize Automation after the rebranding. How would you do that? You could put essentially what's called a custom property on there, which is a key value pair that essentially based off a user choice that they've made, or based off it just being a particular catalog item, you would say, is Apache is true or false? And then essentially you would write a custom fact that would source, because when vCAC clones that VM, it's going to have a text bag on the VM that has all your custom properties on there. You could read that out and then have Puppet parse it to make a custom fact that would then indicate back to the Puppet master that that is in fact an Apache server. This is a little bit more of a complicated solution, but if you have a whole lot of different classes or group memberships that you have to worry about application, there's a variety of ways to do that, and doing this custom facts is definitely one way to do that. The other thing that we mentioned before is just classifying the node based off of the rake API command that we did earlier. So here's our is Apache link, and you can see there if it's true, then it's going to be a member of that group. All right, so here's a sample rake command for the pre-stage examples that I was talking about previously. There's a whole lot of information about the rake API online, but essentially the rake API, it's not HTTP REST-based API. Essentially what we're doing is SSHing into the Puppet master and running this command. So every single one of your commands is going to start right here. All this part right here is just essentially accessing the rake API. And then the command that is relevant here is this one. So we're doing node:add, and then in the brackets we have our VM name, and then these are our group memberships. So this is a la carte model, right? Because how many group memberships do we have? VMware Mandatory, VMware Monitoring, and VMware Apache. So we have 3 groups here that this node is going to be created. Note that this node, you're going to see it in the Puppet console, but it's going to show that it's essentially never checked in because we're pre-staging the node. All right, so here's the same example, but we're talking roles and profiles design pattern. So same thing, pre-stage the node, create it, and we're applying a single group membership, which is role : Apache web server. And because of our design pattern, there's nothing physically in Puppet or that prevents us from putting something in more than one group. It's just a design principle that we've agreed to if we're using this roles and profiles design pattern to essentially make our lives easier. All right, so integration with Puppet, automation platform requirements. This next section, we're going to talk about what you have to look into if you're trying to analyze or plan for your self-service provisioning platform and figure out if you're going to be able to do a Puppet integration. This information is also possibly relevant if you're looking at an integration with some sort of other service, whether it's a CMDB or a IP address management system. You need these sort of hooks in your self-service provisioning system to be able to do these integrations. So let's talk about machine lifecycle. So when we're going to integrate with a shared service provider, with a self-service provisioning platform, essentially first step that we have before is the VM is going to be ordered from your catalog, and then you're going to need an integration point, ideally to be able to execute code before the machine is ever cloned, built, or deployed. So the classic example of this is an IP address management system. If I'm going to get an IP out of a solution like Infoblox or something, I want to know what that is before. We're doing the same thing with Puppet when we use the pre-stage model, which is we're going to pre-stage that node before it actually ever clones. So you want to look into your self-service provisioning and engine and see what kind of abilities it has here. In the context of vCloud Automation Center, essentially what it does is you can put a property on it that says call out to a platform, and you can execute essentially whatever workflow you want. So typically with VMware, we're using vCenter Orchestrator, which is an orchestration engine. And at each one of these stages, it's going to call out to Orchestrator and execute code there. So I'll show you an example on the next slide, but essentially before the machine is cloned, built, or deployed, you need to be able to execute code of your choice. After the machine is booted and the OS is up and stable, you need to be able to execute code of your choice. This is an optional one, but potentially when a machine is edited, you need to be able to execute code and capture that and trap that event or hook into it. An example of this is, say, somebody deploys a database server and they decide when they first deploy it, well, I don't need backups, there's no critical data in here, and they don't check backups. Later on, they work with that system for a while, it starts to become more important, and they put together a test data set. And they want a backup now because they put a lot of work into creating that test data set. It's not production data, but they'd like to be able to recover it because it represents a lot of work. In that case, what you would like, ideally, probably is for them to go into the self-service provisioning platform, click that VM, be able to check the box that they didn't check when they first built it to enable backups, and hit OK. If you have that available in the UI and there's a hook there, then what happens is the automation engine goes out to Puppet, it adds that node group, and then the next time the Puppet agent runs, it installs and configures your backup agent. If you don't have a hook to be able to do that, probably your only option would be to manually load it or to rebuild that VM. And the last thing, and I've heard a lot of mentions of this today, and you don't want to forget about this when you're doing full lifecycle management, is what to do when the machine is deleted. I've heard several people say, yeah, I do Puppet Enterprise Console, but I go in there and there's 500 VMs in there that I don't use anymore and they're dead. If you have the correct hook in your self-service provisioning platform, when the machine is deleted, what you're going to do is do a call out to Puppet and delete or deactivate that node so that you're not seeing all those invalid nodes in your configuration. So here's a screenshot of how we do this in vCloud Automation Center. See a small picture of the catalog over here. You can order your VM, and at each stage, there's a hook from vCloud Automation Center to execute an orchestrator, a vCenter orchestrator workflow. So you see the workflow here for building machine disposing, machine expired, if it has a lease on it, when the machine's provisioned, which is when it's done being built, when it's initially registered, every time it turns on, when it's reconfigured, or when it's unprovisioned. And then you see a small screenshot of this actual workflow. Each one of these items is a scriptable task and would contain code in it to do something like a Puppet node registration. All right, so some key points here. That's just a brief recap of the sort of information we've been over. System administrators are faced with deploying and managing larger numbers of virtual machines. When you add a self-service provisioning platform into that, you probably heard of this term virtual machine sprawl. If you think you've seen VM sprawl, which essentially is saying, oh, we went from physical to virtual, and now since virtual machines are so easy to deploy, we have 10 times the number of servers we used to have. If you have a successful self-service provisioning portal, that number is going to skyrocket even higher, because not only is it easy to deploy VMs, users can do it themselves without having to do a lot of requests and tickets and waiting through IT. That's not necessarily a bad thing. It can be a bad thing, but as long as those systems are being used for productive purposes, it's probably best to embrace that. If they have actual business value, then you want that to occur. If you need to reclaim some of them or resize them because they aren't being very well used and it's not a good use of resources, then there's lots of tools out there to establish that and do that. But the goal here is to meet users' desires and requests and wants, because if you don't, we saw the slide earlier today about shadow IT. Shadow IT is what happens if you don't give users what they want. Without configuration management, there's a gap in automated delivery of VMs, right? So a lot of times you say, oh, we rolled out OpenStack, or we rolled out vCAC, great, declare victory. User can click and the user has exactly what they want, as long as all they wanted was a VM with a bare operating system and no software installed or configured. But a lot of the time, that's not what they want. They don't know how to install Apache or config it. They are, developers, or they manage one application, and they're not used to doing that. So what we see a lot is these solutions get deployed, and then there's a break in the process, because yes, the operating system is built, the system is deployed, but the user can't do anything with it because it doesn't have the software they need installed and configured. So your automatic process terminates with a manual final step. Yeah, your VM's built, the operating system's loaded and updated, but I haven't got around to installing and configuring Apache yet for you. If you're doing that and it's something that your users need, you kind of defeated the entire purpose of having a self-service solution in the first place. And you need something like Puppet to automate that final step and make all the pieces work together so that you're actually delivering users a system that they consume and do something useful with. Without centralized config management, config drift and system standardization can be a huge headache. You all probably already know this. This is probably a large part of the reason a lot of people are here. And it gets even worse with self-service provisioning, because that number of VMs goes way, way up, and you don't have as much insight into them because you didn't build them in the first place. Integration with self-service provisioning platforms typically requires an orchestration engine that can be called from the self-service provisioning platform. So I was referring to vCenter Orchestrator. I recently did some work with HPOO, which is HP's solution for this. There's a whole lot of orchestrator platforms out there. That orchestration platform is typically the glue that glues all these different systems and pieces together. It calls one system, receives data from self-service provisioning, calls Puppet, calls your CMDB, calls your ticket system, puts the information in there, brings it back, puts it back in the self-service provisioning platform, etc. You can try to do this just with a general purpose language like Python or Java or something. I don't suggest that you do that. It's very difficult. I've seen it attempted, and you're kind of reinventing the wheel. Somebody's already had all the problems that you would have if you try to do that, and solved a lot of them. So really look into what's available. There's a lot of solutions out there. If you're a VMware customer, vCenter Orchestrator is free and has plugins for a lot of this. There's a Puppet plugin that's in beta that's coming out relatively soon, and I'm sure that a lot of the other orchestration platforms have similar offerings. All right, so we're finishing a little bit earlier. I did go through some of these slides kind of fast, so I want to open it up for some Q&A and see if anybody has any questions about self-service provisioning integration, and maybe have some discussions there. Up at the very top.
Yeah, I noticed that you're SSHing into the Puppet Master to add the host. Do you ever get any pushback on that rather than using like the API?
Yeah, so the question is SSHing into the Puppet Master, you ever get any pushback on that versus using the API? The last project that I looked at, the HTTP API didn't have all the functions that we necessarily were wanting to consume, such as being able to pre-stage nodes. So it was kind of a necessity. There always is pushback, and there's a couple different solutions there. You can really lock it down. You can do key authentication. You can only allow it from the orchestration engine so that you have a known path that you can inspect. And I've even seen it taken a degree further than that, which is rather than giving sudo access with root access on the Puppet Master to the integration account, you can actually wrap those in scripts that then can be allowed to be executed from an account with less privileges. So yes, I think it's a valid point with respect to security, and I think you're very likely to see pushback on it. But at this point, there is some necessity there. We're hoping eventually down the line, some of these functions will be available through a REST API. Okay, up at the top.
So just to clarify something I didn't quite totally understand. So when you talk about an orchestration engine,
yeah,
what you're referring to is basically saying that when a user requests a given virtual machine, the orchestration engine would take care of provisioning like an entire environment in which that machine would reside, or is that?
Right, so the question is, when we're talking about an orchestration engine, are we talking about that orchestration engine doing the full lifecycle management and provisioning of the virtual machine? And the answer to that is no. I think you're still going to be using a solution like vCAC or OpenStack, which is a self-service provisioning platform. It's just that platform may not do everything that you need out of the box. And in those cases, what you want is that platform to have an API hook that says, okay, before I build a VM, I go call either over REST or whatever is available, some arbitrary code that you as an orchestrator can write. So in our case with vCAC, you order a VM, vCAC goes out to orchestrator and says, hey, they ordered a VM, here's the details, and it says, okay, I'm gonna go create a Puppet node, and then it tries to do that. If it's successful, it says I'm done, and hands it back over to vCAC. vCAC is actually going through the process of talking to the hypervisor, talking to vCenter in this case, and saying, okay, clone this VM, okay, you're done cloning it, turn it on. Now that you've turned it on, like run this stuff to, join it to the domain or inject the keys, and it does its full configuration, maybe even including installing Puppet, or you may do that in your orchestration engine. So essentially what I'm saying is they work side by side and call each other. At each point, that self-service provisioning platform, whether it's OpenStack or the VMware solution, is calling that orchestration engine to talk to Puppet or the other external systems it needs to interact with. Does that answer your question?
Yeah.
Okay, great. Over here?
Would it still be single node orchestration though? Would it be cross node orchestration?
Would it be, you're asking if it'd be single node orchestration or cross node orchestration?
Yeah.
So I think it would still technically be termed single node orchestration, because you're just having that one node be essentially pre-staged and created and classified. There are possible use cases that you would get into cross-node orchestration if you were trying to maybe do something like register it in a load balancer, right? Say you say, not only am I going to deploy a web server and install and configure Apache, after Apache is installed and configured, I'm going to add it to a VIP in my F5 load balancer. In that case, you might be starting to get into cross-node orchestration. But in this particular case, the examples that I was talking about were single node. Does that make sense?
Do you think that it would, yes it does.
Okay.
Would that apply though? Do you think you could make this work successfully for cross-node with the?
Okay, so the question is, do I think I can make this work with cross-node orchestration? And the answer to that would be, I do think you could make it work with cross-node orchestration. It would be a higher level of effort, probably would be more difficult, and really get into some of the stuff we saw with Nagios where you have timing issues. You know, I have to wait and make sure that Apache is installed and configured before I use Puppet to maybe do something like HA proxy or F5 and then do a configuration at that point. So orchestration is all about timing. How do I know when one piece is done and when to go to the next piece? Does the system that I'm keying off of indicate that to me, or do I have to pull and check for myself? So it can become a rather complicated orchestration project, but I think it's completely doable. Sir, over here in the blue.
Well, so, I mean, to answer his question,
Yeah.
do you know that you can do REST API calls to VCO?
Yes.
And VCO would very definitely do node to node.
Right, so he's adding some information to your question, which is, or to answer your question, which is that VCO, in our case, vCenter Orchestrator, the orchestration engine I was referring to, has its own REST interface so that you can call and trigger workflows over REST as well as query them and see what the current status of a workflow execution is. So he's saying you could actually call, for example, in your Puppet code, after you finish installing and configuring Apache, you could call an orchestrator workflow to then trigger the load balancer registration or something like that to do cross-node orchestration. The question is whether or not you can do that in your environment, and a lot of times the orchestration engine can have access to things, but a lot of times security guys get a little bit worried if you're doing orchestration calls from one node to another node in the environment, and they want to make sure that, you know, those accounts and things that you're using for that are secure, and it isn't something that's going to end up in the hands of a user. They want to keep that stuff in a controlled spot. But there are ways that it could be done so that you could do that cross-node orchestration using the VCO REST API. Sir?
And just to add to that, probably we currently do that. But
Okay.
1 year of your consulting services, $7 million.
So there's just a call out to this actually being done at Boeing, and I think I do know the consultant who's on the project who said they managed to pull that off and do it. It was a several $million project. So like I said, the level of effort on doing some of these more advanced cross-node orchestration is certainly doable. It's just a question of how much is it going to cost, how long is it going to take, and is it worth it to you? Is the ROI on there?
You're still there drinking my coffee and eating our donuts.
Yeah, so we're still drinking their coffee and eating their donuts. So.
That's a great point, and the biggest challenge with that is going to be your security people, because you know, at Boeing we've got a lot of security going on. So our biggest challenge was getting the Linux, the COBIT, all the Sarbanes-Oxley folks, all the network people. Actually, the network folks were our hardest. And you brought up another thing I just wanted to bring up also.
Sure.
The requirements of getting, just think about what you need before you order a VM. It needs a hosting and an IP address. So at Boeing, when we first rolled this out, we could only give people DHCP. Even today, we can't do it automatic or static, because we wrote our own hosting IP generation system, and it's got no API.
No hooks into it. So they wrote so he's saying you need to be conscious of this systems that you're using in your environment. They have a self-roll your own system for doing their IP management, but it doesn't have an API. Whereas if you go with a solution like BlueCat or Infoblox or some of the other alternatives out there, you have an API where you can check out IPs and push them back in. It's very important once you start hooking all these products together that they have APIs to be able to do that. And we're lucky with Puppet that we have access in to be able to do a lot of this stuff. Some of the other configuration management tools out there, specifically on the Microsoft side with things like SCCM, can be very difficult to do those integrations. A lot of times, if there isn't an API available or it doesn't do exactly what you need, you can be kind of dead in the water as far as being able to integrate with these systems.
Not at all. You have BCO send an email. This is what we did.
Yeah.
It sends an email, you click reply, it goes back to the REST API, and the workflow keeps going.
Yeah, so there's a workaround mentioned with sending an email and then replying to that, and that and dropping stuff in folders. I've seen it done before. If you can keep away from it, you obviously want to, but we do what we have to make things work sometimes. So, any other questions? All right, well, I think we're probably going to wrap up a little bit early, which is great. We can get to having a beer or whatever else we're doing later today. And thank you very much for your time. If you have any additional questions, I'm going to be circulating around. I can drop a business card or answer any additional questions you have. I know this was a very quick, brief overview, but there is a lot of possibilities here, and I just wanted to kind of scrape the surface and show you some of the integrations that are possible, not only with VMware's product line, but with Puppet in general and a lot of your self-service provisioning platforms out there. So thank you very much.
Thanks, Justin. So we've reached the end of the day. Thank you, everyone who came out today. We hope that you'll continue some of these conversations here in Portland at the Puppet user group that we have every month. And also we hope to see many of you folks at PuppetConf this year, our huge, it's training plus a contributor event plus a 2-day conference. So we have like a week's worth of activities here in Portland. And in the past we've had that down in San Francisco. So we're really pumped to have it here in our home. Yeah. So speaking of continuing conversations, we're going to continue today's conversations at the reception. It's going to be exactly where we had lunch if you go down through the OMSI restaurant. For those of you that are brokenhearted that you're missing the Ducks game, it's going to be on the TV in there, so that'll be there for you. Yeah, we care. Thank you to all of our speakers today. Thank you. Yeah, round of applause. Thank you to Meg, who emceed today. This is her first Puppet Camp that she emceed. Yeah, awesome. Thank you, Meg. And if you see Brianna later and you think that today was awesome because of her wonderful logistical planning and it went really smoothly, let her know, because honestly, this was a really, really nice camp. And thank you to all of you for being so wonderful today. We'll see you at the reception.